Hello friends, welcome to your only channel Times of Code. Today in our series Scala Express, we will see curry. This session will help you to control abstraction in your code following your own control structure way. In previous session we have learned distinct code principles and simplified functions. In this session we will see currying functions and will define our own control structures. So far with function definition we have seen how to pass arguments and list of arguments like I'm using in this example. Old school add x, y, x plus y, and then we are calling the same function. But now with the help of currying function, we can even write multiple arguments or multiple list of arguments. Like I'm defining one function here, add currying. Here if you see, we have got two braces, x colon int, y colon int is equal to x plus y. To call this function, we need to pass two arguments with add currying function as in different braces. After execution, we will have a result 23 as expected. If you closely look here, you will remember that this is the type of partial function which we have already discussed. And I'll show you how we have defined in my earlier session. Earlier we have defined partial add functions and there we have kept is equal to in between. And then we have done x plus y. And there I was giving you a definition called one is bound variable and another one is free variable. So here is a quick recap I'm giving you to our earlier function. We're defining here partial add and then to complete it, partial function references stored in this to complete currying variable. And we are giving 10. Now when we call this to complete currying function with another value 30, it will get us the addition here as 23. But if you observe, we are not using placeholder. So I'll make use of the placeholder now. I'm keeping the exact definition. I'm removing here is equal to sign. And then with partial add function here at a statement 2, I'm defining one placeholder like this. And then I'm calling in similar manner. So here 10 plus 14, it should give us defining with underscore. And then I'm calling complete currying function with 14. So 10 plus 14, it should give us 24 now. Here you can check this value. After execution, we get this value. So that's how currying between function works in Scala. Now moving on, we will see how to develop our own controller structure in Scala. Here I'm defining first class controller structure and I'm keeping as argument one function which will take int and return int. And then we are having another parameter called a which is int type. Here we are having a little calling itself. Function will get called twice here. And now to call this function, I'm writing function name placeholder plus 1, comma 10. And if you see the value which we are getting here is 12. What happens exactly when we write function like this is the function body which is placeholder plus 1. So first time this function will get called with 10. So 10 plus 1, it will become 11. Now the next time it will get called with output of first function. So that means 11 will go here and plus 1. So it will give us 12. That's what happening here. We have seen similar cases in one of the earlier session for first class methods. Now moving on, we will have another example. So in this example, in this store operation, we are defining two parameters, store open type of boolean and currency denomination type of vector. This function will not write anything. That's why we are keeping unit. Here I've defined one condition called if store open. Then we are having try, catch and finally block. In this try block, the first statement I'm keeping is debug message block. Then I'm defining today transaction, which is 10,000. Then I'm keeping one debug statement again, and this debug statement having little transaction. So total today transaction value will get divided by currency denomination which we were passing here. And after this operation, we will get the total number of checks which we have received from today transaction. In catch block, we're defining case for arithmetic exception. In case we end up with arithmetic exception while doing this operation, we will give this debug message. And then finally, we are keeping similar debug message as earlier. Now here I'm partially defining this function called store operation with placeholder and the reference I'm keeping it complete day. And to complete a day, I'm passing the number of denomination here. So this is my way to control. First I was passing the store open boolean and then I was passing the currency denomination. You can define your own way while using currying with partial functions. In theory, we have covered today's content. Now we will do the practical. So we will go to IntelliJ now. This is the first window you will see after opening your IntelliJ. Now I'll create another package called curry. In this package, I'll define one Scala worksheet called example now. The very first example we have seen earlier today is old school addition. So that I'll define it as it is, and then I'll execute it. And now we have got sum. I was keeping 10 and 12 here, so we got 22. Then we have seen how we can define add function while using curring. So here, curring add, I'm keeping two parameters here in two separate braces, and then we are doing the addition. I'm calling it. The function has been defined after execution, and we got as we expected by giving 10 and 13 here. Now after this function, we have seen how we can define our partial functions. Likewise definition we have seen earlier as well. Here I'm defining partial add, keeping one parameter here as x, and then I'm defining one y. Then I'm doing the add. I'm calling with 10. To complete curring, I'm saving here the reference variable of partial add here. I'm calling again with 13. So now when we execute, okay, function successfully defined, reference we have successfully defined for this function, and then we are having 23 as we expected. This similar objective we can achieve by using placeholder as well. So this is proper curring I'm doing. Previously what we have done is partial functions. Now what we are doing is curring. So here I'm defining one add, and then I'm using placeholder here for partial definition differences in complete curring I'm storing. And then I'm calling with 40. So when I execute now, it gives me 24 as expected. After this example, we have discussed how we can write first class functions, which we have seen earlier, and we can control structures there. So here I'm keeping one function, which is taking two parameters. One is function, which would take int and return int, and another one is parameter of int type. So here function is calling itself with a parameter, which we are passing here. And this is what function we were talking here. So placeholder +1 we have defined here, and 10 we are keeping as a. Now when we call this function, let's see what is the outcome. So it is giving us 12. You may be wondering how this 12 is coming, because here we are passing 10 and then it should be placeholder +1. I'll explain you how. Because this function is calling itself. So technically this function will get called twice. First it will get called on 10, and this 10 will go inside as a placeholder +1, so it will give you 11. Now next time 11 will go as a placeholder, and then 11 +1, 12. So 12 will be the outcome out of this first class controller structure functions. Now after this example, I took example from one of my earlier session, which was from store open, where we have seen partial functions earlier. So now I will define as a curring way. Here I'm defining one function, store operation, and we will define one boolean parameter called store open, and then I'm defining one int type of parameter called currency denomination. So here we are applying one condition called if store open. Since it is a boolean value, it will check for true and false. If it is true, then it will move forward inside. Here I'm keeping three blocks: try, catch, and finally. In this try block, we are having first debug message, which we have discussed earlier. Here I'm defining 10,000 as today's transaction. Here we are dividing this today transaction with currency denomination, and then we will get the number of check. One case statement I have written here in catch block for arithmetic exception. And then I'm calling finally with debug message. So now we will see how to call this function. Since I want to control my function structure, so I'm keeping it with placeholder here. So first I'm keeping true. This true will go inside for store open as argument, and then it will get a call to store operation. Since we have defined this function as a curring, so it will allow us to call in partial way. Here I'm keeping the reference of this function in complete day, and next time I'll call complete day function with currency denomination. So let's say I wanted to see currency denomination of 100 for today's trade. So I'll write 100 here, and then I'll execute. Since our total trade was 10,000, we have got $100 total checks. And this is our usual debug message. Let's take a condition now for coronavirus, where all the stores are closed and they're not having any transactions. So since they are not having any transactions, our default today transaction value will get nullified and currency denomination will get 0 and we will keep it as 0. So when I execute complete day with 0, 0 will go as a currency denomination and this currency denomination will try to get divided by today transaction. Any value get divided by 0, that will produce arithmetic exception in mathematical term. Since we have got case statement here, this exception will get caught and we will get this debug message. So here is the outcome of our execution. First, good morning is store open true. Oh, it's deadly corona. That's why you have not got any currency check. And then good evening is store open true. With this example, we have completed today's session. I hope you enjoy the content today. You can comment, share, like, subscribe my channel. Thank you. Have a good day.